So this is the Caribbean island of Puerto Rico and the nasty vector that resides there, which means tonight I'm here to talk to you about dengue fever epidemics in Puerto Rico and how our team is trying to quantify the contribution of environmental factors to these events. So imagine, you're on a tropical island, you're laying on the beach, taking in the sun, and bam, you're joined by a scourge of mosquitoes. And trust me, it's much too late for DEET now. You're covered in bites. Now, the mosquitoes on this island might not be sci-fi scary, but the disease that Aedes aegypti spreads should frighten you. Dengue fever is the fastest growing vector-borne disease in the world, with 400 million people infected globally each year. But let's take it from the mosquito's perspective. It's not your fault you're infected with dengue, or that you spread the virus through your saliva. You're just a gal about town, seeking your next blood meal, getting in the mood for some baby making. The next step, of course, is to find a home for your little fellas. These water receptacles were left out in the rain by humans and will provide the perfect spot to lay your eggs. But if they breed, we humans will bleed, and dengue will continue to affect people. Now, the people of Puerto Rico have tried to use mosquito nets and pest control in order to stop dengue, but Aedes aegypti is persistent. And trust me, it's not rainbows you'll be puking for 3 weeks after you're infected. The people of Puerto Rico are affected through their psychology as well as their health, and finally their economy. So at NASA Develop, we've teamed up with the University of Puerto Rico as well as the Center for Disease Control Dengue branch in order to study these epidemics. There have been 3 major recent epidemics in Puerto Rico, the largest in 2010, which had over 7,500 cases of dengue fever. So we focused on the island of Puerto Rico from 2009 until 2013. Previous research has shown that dengue fever epidemics are related to environmental factors, including precipitation. So we use these satellites, to get remotely sensed and modeled data in order to study epidemic and non-epidemic periods on the island. The environmental variables that we used included land cover and elevation as the habitat input into the model, as well as confirmed dengue fever cases, land surface temperature, total precipitation, and relative humidity. These variables were put into monthly time steps and input into the maximum entropy species distribution model, or MaxEnt, which output dengue fever risk assessment maps, as well as the relative importance of these variables to confirm dengue fever cases. Let's talk risk. This dengue fever risk assessment map is from a period before the 2010 epidemic. The red hot areas indicate high risk, while the cooler areas indicate lower risk. As we can see, even in a non-epidemic period, there's still risk of dengue fever in Puerto Rico. As we zoom into the San Juan area, we can see that the highest risk is in urban areas as well as coastally developed areas. The lowest is at highest elevation, where there are fewer people and less mosquito habitat. At the peak of the epidemic in 2010, there was increased risk across the island of Puerto Rico, except for the higher elevation areas. And trust me, not your DEET would go that high. So, as we take a closer look at the San Juan metropolitan area, we can see that the cities of San Juan, Bayamón, Carolina, and Caguas are all under increased risk for dengue fever. So we have to ask ourselves what environmental contributors are causing this risk. Land cover, elevation, and precipitation are the top contributors to dengue fever cases. In periods of epidemic, the importance of land cover increased to 67%, while the importance of elevation and precipitation fell to 10%. My first choice would be to annihilate the vectors, but our future work will include the use of a habitat assessment map in order to narrow down our study area, as well as to focus in on the environmental contributors, the ones we went over today and the ones we'll be adding. So, in summary, our results show that the disease spreads through low elevation urban areas with increased precipitation, and MaxEnt is a viable option for dengue fever risk assessment. Like that on Facebook. At the end of the day, it's our hope that using Earth observations will allow the CDC to improve their public outreach and health education programs in at-risk communities in Puerto Rico. So finally, I'd like to thank our partners at the CDC, the Department of Health, and the University of Puerto Rico, as well as our advisors at Ames Research Center. Thank you.